I've been advertising a lot of lasts lately. Guys, for those of you in pre-algebra, guys and gals, this is the last of the last of the last of the videos for the entire year. That's for you. Now, Algebra 1, depending on the time of day, is still going to have one to watch a little bit later. That does not mean, however, that this is the last of the last of the last of all classes and all work that you're going to do for the rest of the rest of the year. Remember what your final is going to be. I gave you that information yesterday in English class, what your final is for math. And so after tomorrow, which is Wednesday, and Thursday, both those days are going to be taking your test. Alright, and so you'll have 2 weeks to complete your math final. Make sure you get that done and turn it into me in a timely manner. But outside of that, guys, this is it as far as videos go of any kind. We're done with new information already, but this is just test review, and we're going to review in the first segment of the video the first half of the test. Make sure that you get a pencil out, preferably. I don't like those pens, not for math. Get a pencil out, if you will, and write down on a separate sheet of paper. Guys, I don't care if you want to write this on your test itself. Remember, kind of like last time, these are extraordinary circumstances. And by the way, this is an admittedly, an extremely difficult test. And so I'm going to give you lots and lots, yes, and lots of help on this test. I'm going to at least give you the formula, in some cases formulas, that you'll need to do every question basically on the test. Okay, that's the tough part, so it'll help get you set up. Of course, from there, you're still going to have to do all the calculations and figure out the answers. But make sure that you write down these formulas. And also, there are a few of them that are very difficult even yet, and I'm going to help you to identify some of the numbers on just several of the questions. So make sure that you have your pencils ready, and let's get right to it. Let's not take up any more time than we need to take up. And so we're going to start with number 1 on your test. Okay, number 1. And for numbers 1 through 4, what you're going to be doing is finding the area. Notice, not volume. That's just something we did at the end. We'll do that some on this test, and more so toward the end too. But for right here, we're just finding the area, okay, of each figure below. Be sure to include units, as we've done throughout this chapter, in your answer. And because all of these 1 through 4 are going to be dealing with area, because all of 1 through 4 is area, don't forget it's not just units, but because it's area, it's units squared. Every one of those on 1 through 4. Okay, so what kind of information do you need for a parallelogram in number 1? What is the area of a parallelogram? It is A equals the base times the height. Okay, A equals the base times the height. And I do want to give you a helpful hint here, and that you might want to look at that dashed line, okay, the dashed line that has a measurement on it for one of those 2 important numbers. And for the other important number, you might want to look at the sides that are parallel to one another as a parallelogram. Okay? So that's a strong hint. Look at the 2 sides parallel to one another for one of your numbers, and look at the dashed line with the 90-degree angle. Look at the dashed line and the number attached to it for the other one. Okay, number 2. How do I find the area of a trapezoid? The area of a trapezoid. My formula for that, guys, is going to be A equals 1/2, open parentheses, one of the bases times one of the bases plus, I should say, the base on the other side, parallel to it, close parentheses, alright, and then you're going to multiply, once that's simplified, 1/2 times this, simplify the 2 bases, times the height. Okay? So I'll leave you to figure out which of those numbers goes where. But that's a very strong hint. Number 3, the formula that you're going to be using for the area of a triangle is, of course, 1/2 times the base times the height. And please allow me to suggest to you that the base and height numbers come from the all-important 90-degree angle that those two length segments form. Okay, those two important numbers are going to come from one side and the other side of the 90-degree angle. And use those in the formula. A equals 1/2 times base times the height. What about the instance of another trapezoid in number 4? What is it that I would do here? Well, this one's a little bit different, okay? This one's a little bit different. How is it that we're going to find this one? I want you to look at the helpful hint that I've given you. Find the area of a rectangle, okay? Find the area of a rectangle, and in doing that, you're going to use the length times the width, okay? And you'll use the longer of the two options for the width, all right? And once you've done that, subtract from it the area of a triangle. Now, this one, guys, I feel like is challenging enough. I feel like it is challenging enough that what I'm going to do on this one is I'm going to actually supply you with the numbers that you're going to need for that triangle. Okay, I'm going to supply you with the numbers that you need with the triangle, which are, of course, the area of the triangle is 1/2 times b times h. That's from where the 1/2 comes. But the base is going to be 3, and the height is going to be 4. Is that a helpful enough hint for you? You guys like that one? Okay. So for the area of a triangle, just use this right here. Okay. You need to find yourself the area of a rectangle there, and then subtract from it the area of a triangle, which is going to be these numbers multiplied together, and you will be just fine if you do so. Number 5. Find the length of a rectangular plot of land that is 150 feet wide and has an area of 45,000 feet squared. Of course, since it's the area of a rectangle, my formula and your formula is going to be A equals length times the width. Area equals length times the width. And if you look back at your problem, you have the area that's given, so you're going to plug in a number for area. You have the width that is supplied, so you're going to plug that in as well. And what you will not have is L. And so you'll need to solve not for A in this one, but solve for L. And also your units, therefore, are going to be just units themselves and not squared, because you're not finding the area even though you're using the area. Okay, number 6, find the height of a triangle with a base of 8 meters and an area of 16 meters squared. And so similarly, the formula that we're going to use in number 6, A equals 1/2 times B times H, because it's the area, or I'm sorry, it's the height of a triangle that we're trying to find. Although, once again, we're given the area, guys. We're given the base, and we're trying to find height. So I have a number I'm going to plug in for A that I'm told in the problem. I have a number I'm going to plug in for B that I'm told in the problem, but I'm going to use those to calculate the height. And again, that would be in units and not units squared, because I'm finding height and not area, even though I'm using area. Number 7, a revolving sprinkler head sprays water up to 20 feet from its location in the lawn. What is the maximum area that one sprinkler head can water? And obviously use 3.14 for pi. Okay, so we are on number 7, and the formula that we're going to need for that one is the area of a circle. The area of a circle is A equals pi times r squared. A equals pi times r squared. And I want to give you this note to put either in your notes or on your test. I think this one's challenging enough. I just want to make sure that you understand and don't overthink this one, that the radius is 20. So that number that you're given is the radius. So that's going to be a really easy answer, almost 3 points with that information. Numero 8. Find the circumference of a circle that has an area of 78.5 centimeters squared. Find the circumference of a circle that has an area of 78.5 centimeters squared. Now, this one's kind of challenging. What you have to do is, once again, use the area that you're given, okay, and plug that into the equation to solve for r. And once you get down to r squared equals some number, you're going to need to take the square root then to solve for r. So make sure to do that. Take the square root. Once you get down to r squared equals some number, then take the square root of both sides to solve for r, and then you're going to use that information for r to plug into the formula of the circumference for the circumference of a circle. So after you get done using this formula to find r, then you're going to plug in the value of r into the formula for the circumference of a circle to find what the circumference of that circle is. And it's that part that really is going to be your answer to the equation. But you can't solve that part until you first find the area of the circle itself. Number 9. Find the area of the shaded region. Find the area of the shaded region. If you will notice, guys, there is a circle, okay, on number 9, that the big overall shape that has some shading and the other shapes inside of it, the whole thing is like this, which means, of course, that it's a circle. So what you're going to do is find the area, based on the information that you're given, find the area of that circle, and look back at what the a prior question, if you need to. I've already given that to you. Or your notes, look at what the formula for the area of a circle is, find it, all right? And then from that point, what you're going to do is find the area, not for one, but notice 2 triangles. Not one, but 2 triangles. And for those 2 triangles combined, then you're going to use that info, the area of those triangles, and subtract it from what you found the area of the circle to be. And once you subtract the area of the triangles, plural, from the area of the circle that you already found, then you're going to have your answer, which is the area of the shaded region. Number 10. 2 similar polygons have corresponding sides in the ratio of 9 to 16. 2 similar polygons have corresponding sides in the ratio of 9 to 16. Understanding that, we're going to answer 10a and 10b. So 10a, what is the ratio of their perimeters? What is the ratio of their perimeters? I've given you nice hints on A and B. Look, the ratio of perimeters is equal to the ratio of sides. Okay, we're trying to find the ratio of the perimeters. If you look back up, before we even begin 10a, the early part of number 10 tells us what their sides in ratio are. 9:16, meaning 9 to 16. And if the ratio of sides, 9 to 16, is the ratio of the perimeter, which this question is asking, what 2 numbers with a colon between do you think I'm going to write in 10a? It's extremely simple. No new information needs to become up with, just as a heads up. So you take that and do with that what you will. That's as strong of a hint as I can give you without just saying, hey, write this in the blank. 10b. What is the ratio of their areas? What is the ratio of their areas? Okay, here's your helpful hint. 10b. the ratio of areas equals the ratio of sides, which we already have. We were told that in the very beginning. So the ratio of areas equals the ratio of sides. However, those sides, top and bottom, okay, if expressed as a fraction, or if you have them as number, colon, number, as we're told in the very first part of number 10. In other words, guys, for 10b, all you need to do is square the 9, colon, and square the 16. And you're good. You're golden. And those can also be expressed, by the way, as a fraction. Either one of those is correct. But those are the two ways of doing that. Number 11. Two similar triangles have perimeters in the ratio of 9 to 25. If a side of the first triangle measures 6 inches, what is the length to the nearest tenth of the corresponding side? Now, I feel like there's enough challenge to this one. I want to help you out on 11 and 12 in a pretty sizable way. And what I want to do is go ahead and give you how you write the corresponding perimeters, the corresponding ratio of 9 to 25. Again, remember I told you, you can write it as 9 colon 25 as the problem does, or mathematically a little bit more if you're doing calculations, you can put it as 9 over 25. And here you want to do it 9 over 25 because the perimeters, or the perimeter of the first one, which is 9, has a side in it that measures 6 inches. And remember, you put that information in the same shape across from one another, perimeter as compared to its side, or area as compared to its side, that we'll do here in just a minute. And you do the same thing for the second one, which has a perimeter of 25, but we don't know what the corresponding side with the one that is 6, and it's a similar shape, is. So guys, here is your problem that you need to solve. 9 over 25 equals 6 over x. And if you know how to work it from there and solve it, you're in good shape. Number 12. Two similar polygons. We did triangles in number 11. This time it's two similar polygons have corresponding sides in a ratio of 2 to 3. Given that the area of the larger polygon is 18 centimeters squared, what is the area of the smaller polygon? Okay, now for this one we're told that the ratio of these two polygons is 2 to 3, or 2 over 3. But what we're trying to find is area of the smaller, but we know area of the larger. 3 is larger than 2, and therefore the area of the corresponding side needs to go straight across from 3, which is 18. That's the one we know, the larger. What we do not know is the area of the smaller in relation to its side. Now, how do we do this? Remember, the ratio of areas right here is equal to the ratio of the two sides and squared. And so what you need to do on this one is square 2/3, okay? Square 2/3, and then you're going to, after you have that simplified, have just one fraction right here set equal to this over here, and then you do what other mathematical process you would do to solve from that point. Alright, so those are numbers 1 through 12. I'm going to pause for just a moment. I'm going to erase this, and then I'm going to write the final part of our test review on the board, and we'll discuss it from there. Guess who's back, little baby Sasquatches? Okay, you ready to finish this up? I too. So let's look on to number 13. Do you guys see why I'm giving you all of these formulas for these problems? Listen, I've told you guys, I'm really proud of you for sticking it out, just in all honesty, in a class that is really above your level. And I don't mean that in any derogatory way. I mean it's a real testament to you that most of you just, really this is beyond where you are right now. This is some extremely difficult pre-algebra, maybe more like some really pretty tough Algebra 1 stuff. So thank you guys for giving it all that you have, and I'm helping you out in a big way, because this is a tough test and these are difficult problems. So here we are, number 13. Let's look at it together. You have your test out still, hopefully. Okay, number 13, surface area. Find both the surface area and the volume for each solid. Use 3.14 for pi and round the answer to the nearest tenth. Include units in your answer, which are obviously going to be units squared for area and units cubed for volume. Okay, number 13. Actually, for 13 and 14, each one of these is going to have 2, each shape. Okay, and so that's the case with 13 and 14. We are dealing with a triangular prism. The base is a triangle. It's duplicated on both sides. It's a triangular prism, and so what we're trying to do is find the surface area of this triangular prism. The way that we're going to do that, guys, we need 3 different formulas. Okay, stay with me here. You remember doing these 3 different formulas. The first one is capital L, which is lateral surface area. You have to find the lateral surface area, and you do that by adding together all 3 sides of the triangle, okay, which are the base for the perimeter. So find the perimeter by adding together all 3 sides of the triangle, and then multiply it times the height. Okay, and on this one I'm going to help you out a little bit in that the height is the bottom rightmost number. Okay, and see how that line connects the 2 bases, the 2 triangles. Okay, and that's why it's the height. So your lateral surface area equals your perimeter, which is adding together all 3 sides of the triangle, times your height. And then you need to find base, which means capital B, the area of the base. Now notice there's another base, a lowercase b, which is only the length of one side. That's not capital B through all of these, that's lowercase b. And so the area of the base is measured in the area of the triangle, because that's what the base is. 1/2 times little base, or the length of only one side, times the height. Okay? And then what you're going to do for surface area is take the lateral surface area and add to it your base, but times 2. Because remember, there are 2 bases in a triangular prism. So all 3 of these formulas are going to be necessary to come up with the correct answer for the surface area. And with each one of these, I put it in the order that you need to calculate things. Okay? So if you start here, and then you move on to that, and then you combine those 2 things that you found in surface area formula, then everything will work out very well. Number 14, find the volume of the same shape. How do I do that? Well, I first need to find the area of the base. Well, actually, I've already done that. Number 13, feel free to recalculate if you want to make sure you're correct. But find the area of the base, and since it's triangular, that's going to be the area of a triangle, which is 1/2 times base, little b, times height. And your volume then is going to be the area, big B, okay, the area of the base times the height. And that's all on 14. For number 15, find the surface area of this pyramid. Find the surface area of a pyramid. How do I do that? The lateral surface area equals 1/2 times the perimeter. Okay, and if you'll notice, the perimeter is in what, the perimeter of the base, that is, the perimeter of the base, that base is what kind of shape for that pyramid? It is a square. And so you're going to add together those 4 sides, or if you want, just take one side and multiply by 4, same difference. But I just keep it simple and say just add the 4 sides of that square together, okay, and multiply that times the little l length. And with this one, I want to tell you it's the dotted line on the right side. Okay, it's the dotted line on the right side is little l. So lateral surface area equals 1/2 times the perimeter, which is a square, plus, or I'm sorry, times little l, which is the dashed length on the right side, going from the base all the way up to the top. It's an unlucky number too. How's that for another strong hint? Okay, and from that point, what are you going to do? Well, you also need to calculate B, which is the area, big B, area of your base. And since it's a square, you just take one side of that square and square it, multiply it times itself, and then for surface area of a pyramid, that is, you are going to add together the lateral surface area that you found, plus the base, the area of the base that you found, and then you will have surface area. Number 16, same shape but the volume. Same shape but volume. Okay, for this one, you're going to need the area of the base, which again is a square, so it's one side times itself. That's the area for a square, a side squared. And then I'm going to give you guys H that goes up in the middle of that pyramid, capital H, okay, the height there. Listen, you're supposed to have to use the Pythagorean theorem to find that out for yourself. I'm just going to give you the height to cut you some slack and to throw you a bone here. This is crazy. And so the height, guys, is 12. And I take these two pieces of information to calculate volume. Volume of a pyramid. Volume of a pyramid is 1/3 times the area of the base that you already found, which is a square, times the height, which is 12. Okay, number 17 and 18 are going to deal with a cone. And so we're trying to find in 17 the surface area of a cone. Once again, for L, they expected you to use the Pythagorean theorem to figure out L. I know you could do that, but when you're already calculating two different things, three, I mean, that's a little absurd. And so I have given you L, little l that is, which is 5. You don't need to calculate that. Just write that toward the bottom right of that upside down cone. L is 5. And look, you still have 3 pieces in this one. So you would have had 4 calculations, major ones you'd have had to have done. That's unfair to expect that much out of you. But you do need to find lateral surface area still, which in the case of a cone, lateral surface area equals pi times the radius times what I gave you, lowercase l, which is 5. Okay, separately now, find the area of the base, which because it is a circle, if you'll notice the base of a cone is a circle, therefore the area of the base is pi times r squared. The area of the big B base is pi times r squared. And then what you're going to do is take those two numbers for your surface area and you're going to add them together. Big L, lateral surface area, plus the area of the base, big B, is going to tell you what your surface area is. Then as far as the volume of a cone goes, you need these two formulas. The area of a base, which again you already know that, you've already figured. That's going to help you with each one of stepping stones because you're using the same shape twice, one for surface area, one for volume. So on 18 you're going to use what you've already found in 17 really. The area of the base, which is pi times r squared. Feel free to recalculate if you want. I wouldn't if you're comfortable with your answer. And then use that info. V equals 1/3 times B, the area of the base, big B, times H, which is the height. Okay, and that's, of course, the only other number that we're given that goes up from what's the top of the cone, but it's upside down, it's a dashed line straight up and down, is big H. Okay, that's the number that you need to use. Alright, so for numbers 19 and 20, we're dealing with a cylinder. How do you find the surface area, number 19, of a cylinder? Lateral surface area first equals 2 times pi times the radius times big H height. Alright, that's how you're going to find the lateral surface area on number 19, and those numbers, there's only 2 of them and they're really self-explanatory. And the second formula you're going to use is, since a cylinder, its base is a circle, the area of that big B base is going to equal pi times r squared. pi times r squared. And then you're going to use those two pieces of info like we had before for your surface area to add your lateral surface area, what you found big L over here to be, plus, notice 2 times b. 2 times b. And, or 2 times the area of your bases. And the reason for that, look at the cylinder. It has matching bases, one on each side. And so the area of those bases you're going to have twice, because there are 2 of them that are aligned parallel to one another. Okay, so that takes us through, oh, we haven't done 20, have we? Oh, we need to do 20. No, let me skip over that one with you. Now for the volume of a cylinder, 2 formulas that are really important. The base we need to calculate, which again we've already done, so that makes it handy for every one of these guys. But the base, because it's a circle, is pi times r squared. And then just take that area of the base that you just calculated, plug it in for big B, and volume equals the area of the base times big H, which is height. Alright, so that one's really not too tough. Really, I mentioned it when we went through the studies themselves and the individual units. I actually think volume may be easier to find than some areas, like lateral surface area and certainly surface area. Number 21, how do I find the surface area and the volume of a sphere? Remember, a sphere is just a 3-dimensional ball, essentially, like a basketball. My formula that I need there, only one of them. It's getting easier, isn't it? So stick it out, and then it'll get easier as you go in ways. Number 21, area of a sphere equals 4 times pi times the radius squared. That is a very easy one compared to these much more complex ones we're doing. Number 22, how do I find the volume of a sphere? Just one handy-dandy formula. That's it. Volume equals 4/3, the fraction 4/3, times pi times r cubed. Okay, not squared this time, but cubed. And that probably makes some sense since we're dealing with volume. So, number 23. A dairy is designing containers to hold 2 liters of milk. If the portion of the carton that will hold the milk is a square prism, with the sides of the base being 8 centimeters long, how tall must this portion of the container be? Note, 1 liter equals 1,000 centimeters cubed. And so what I've done right here for you is helped you out and go ahead and furthering that conversion factor for you into what you need in actual units. Since you're dealing with 2 liters equal 2,000 centimeters cubed, based on the conversion factor we've already been given. So, 2 liters equals 2,000 centimeters cubed. Now, the reason that is important is because we're going to be using the formula volume equals base, the area of the base, big B, times the height. And I want to go ahead and mention to you that the volume is going to be the 2,000 number. So for V, you're going to plug in 2,000, okay? And for the area of the base, that's going to be 8 squared. Okay, so 2,000 equals 8 squared H. That really should help jumpstart you in the right direction to finish, though, guys. That's not done. It's not even close to being done. But finish solving that equation. I say it's not close. It's not very far away at all, actually. At most a 2-step equation. But finish that equation and everything should be good there. Number 24, I almost said Jasmine. No, Jameen. Jameen measured the circumference of her basketball, a sphere, to be 31.4 inches. What is the volume to the nearest cubic inch of the basketball? You need 2 formulas for this one. First, find the circumference and use the formula C equals 2 pi r, times the radius. 2 times pi times the radius. Find the, use this formula. I said find the circumference. But actually what you're going to be doing, because you're given the circumference, is you're going to be plugging that in and you're going to be solving for r. Okay? Even though you're using circumference formula, you're solving for the radius because you plug in the circumference that you're given for C. Easy to get that mixed up, even for me. And then what you're going to do with that information that you find for the radius is you're going to plug that in for R, whatever you find the radius to be, work out the problem, and you are going to then know the volume of the basketball. Okay, that will tell you the volume of the basketball. So 2 formulas are needed on that one. Number 25, and last and I would say not least. Noah's Ark was approximately 450 feet long, 75 feet wide, and 45 feet high. How many square feet of boards would Noah need for the outside of the ark? Guys, I want you to look at this. This is next to impossible, okay? Just to set it up correctly, it's pretty challenging. So, what I've done is I've set up the equation as far as what you need to do, really in non-algebraic form, just simple math. And if you will take 2 times, meaning open parentheses, that's 450 times 75. That's not 450.75, not a decimal. Okay, we understand that? The reason that, and here, maybe it'll help if I do it this way. You know how we don't put x's for times anymore because we use x so much in algebraic equations? What I'm going to do is I'm going to go ahead and put times, okay, but as an x. Does that help any? And so those are not decimals, but it's 2 open parentheses, 450 times 75 plus 450 times 45 plus 75 times 45. And it's all those dimensions together. Now, this is key, guys. You don't work this from left to right. You do order of operations first. Do order of operations first. And that is my heavy hint for how to get the correct answer on number 25. Okay, listen to me. I expect plenty of struggles on this test. Don't think that I expect perfection out of you and everyone get 100%, and truthfully I don't expect anyone to have 100%. It wouldn't surprise me if maybe it's even the best grades a little ways away from, as in decent distance away from 100%. I get it. This is one of the toughest tests and probably the toughest one that any student could take in pre-algebra, okay? All I'm asking is this: give it everything you have, all right? And everything will be fine, and I'll make sure that you're rewarded in the end if you give me full effort. That's the one thing I ask. If you don't turn it in, grade-wise, you're going to be in trouble. If you don't try hard, if you get halfway through it or a quarter of the way and say, nah, I quit, you'll be in trouble. Just work hard all the way to the end, and I'll make sure that you're rewarded for that, okay? Listen, guys, in case we don't talk anymore before this, we might not. I want you to know how much I have really enjoyed the year with you. It's been a blast. I know it's been a challenge for all of us in many different ways, but I have just really enjoyed the time with you. It's been a treat to get to know you. I hope maybe I'll be teaching next year. Maybe you'll be at TCCS next year, and I hope our relationship and our fun times will continue to get to develop together. But I appreciate everything that you've done. Go ahead and knock out this test. Get it sent to me. I'll get that graded. Do your final, and we're off to summer break, guys. I love you, and I really mean it when I say I appreciate you and the work that you put in this year. Adios, amigos.